Hi, welcome to our math. Today I'm doing a series of videos on rationals. Right now I'm specifically doing the adding, subtracting, multiplying, and dividing. I have 4 problems on the screen right now, and I probably can do all 4 of these pretty quickly. The reason is this first one, the only one that's really challenging because it's subtraction, which means we need a common denominator. It looks hard. And what I find students doing is they see a minus 11 and 11 minus a as 2 different denominators. They're not identical. And they start multiplying. But the problem is if I just take 11 minus a and rewrite it as negative a plus 11, because there's an implied addition sign here, and I factor out a negative, I can rewrite this second denominator as negative a minus 11. Well, there's a thing about a fraction. There's a numerator spot, an out front spot, and a denominator spot. And if you have a negative fraction, you can write the negative in any of those 3 spots. However, if you have a negative in 2 spots, like we do here, out front, down below, they join forces for good. In other words, this becomes plus and this becomes positive, and now our denominators are the same. Now, if I hadn't done that, I would multiply negative to top and bottom over here. My answer, I'll show you what it would look like if I had done that. Now I have 8a plus 3a over a minus 11, which is 11a over a minus 11. Had I not done the minus and negative, and I had left this minus and multiplied it through, I would have ended up with negative 11a over minus a minus 11. It kind of rankles me to have this many negatives. I really don't like it. I would want those canceled, or you could write it negative 11a over negative a plus 11, which is a much more comfortable answer. These can't cancel because this isn't factored, there's addition. This is my favorite answer, this is my second, and that one kind of is uncomfortable because of the canceling of the negatives. I would probably take a point off because the negatives cancel. This one I wouldn't because it's not factored out. Okay, 8. 8 is multiplication. This is really over 1. Factor first. 2 numbers that multiply to 11 and add to 12 are 1 and 11. I'm going to rewrite this as 1 numerator over 1 denominator. I'm going to put the negative up top. Once again, I can go to any of the 3 spots. I like it in the numerator the best. That way I'm not hiding anything. Negative 11b, negative 15b, b plus 11, b plus 1, all divided by. The only thing in the denominator is that b plus 11. They cancel. So I have negative 15b times b plus 1. Okay, my next example for your viewing pleasure is, this one's a big one, isn't it? It looks pretty intimidating. I'm going to put a rectangle around the part with the division because division means flip and multiply, and it just means flip and multiply the exact fraction after, not the one before, not 1, 2 after. This one's being multiplied, just this middle one. Okay. Now, once again, I have 6 parts to factor. 6z plus 6, that's not too bad. I can just take a 6 out and have z plus 1. All right, 2 numbers that multiply to negative 2 and add up to negative 1. That's z minus 2 and z plus 1 times. This box says, flip me over, find the reciprocal. All right, z squared minus 4 is going to become my numerator. That's a difference of 2 squares. Z plus 2, z minus 2. If you need any tutorials on any of these factoring parts I'm doing, I do have a bunch of videos on how to factor. Please go to those videos if you have questions. Now, this 3z squared plus 21z plus 30, I'm going to kind of pull it down here. I can factor a 3 out. If I take a 3 out, I'm left with z squared plus 7z plus 10. Okay, that's a little bit simpler. 2 numbers that multiply to 10 and add up to 7 are 2 and 5. Don't forget your 3. 3, z plus 2, z plus 5. Next numerator. Well, there's a z in both of these and a 4, so I can factor out a 4z. Always look for your greatest common factor. It will make all your numbers smaller, which can only help. And this is a binomial. There's no squared. That's 2 means we're really looking to separate to 2 z's. 2 z's, but here it's only 1, here's only 1. I can pull out an 8, I'm left with z plus 4. Now that it's all multiplication and all factored, here comes the fun part, canceling. Z plus 1 divided by Z plus 1 is 1. Yay! Z plus 2, Z plus 2, Z minus 2, Z plus 5. But then we have our numbers as well. 4 and 8. 4 goes into 8 2 times. 3 goes into 6 2 times. 2 divided by 2 is 1. Our numbers go away. Got to make sure we don't miss the fact that there's a Z left. So we have a Z left in the numerator. 1, 1, 1, 1, 1, 1, 1, and a Z plus 4 in the denominator. And once again, I'm putting parentheses around it so you don't accidentally cancel your Z's and make it 1/4. It isn't 1/4. It is Z divided by Z plus 4. And then for my last example of these 4, this one looks kind of hard, but it's really, really not. The two numbers that multiply to 30 and add up to 13 are 3 and 10. So I have t plus 3, t plus 10, and if I can suggest to always put that tail on your t so it doesn't look like addition, divided by, that's just fraction, divided by t plus 3. Those divide out to be 1, and I'm left with t plus 10. Awesome. Okay, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I will see you on the next video. Thanks!